In this video, we are looking at scenarios wherein we have quadratic equation in the denominator which can be factorized and linear equations in the numerator. The presence of linear equation, it does not make a difference, to be honest. If it's there, we are able to handle. If it's not there also, we are able to handle. We have forms which are of a minus b the whole square, a plus b the whole square. Those two we will be able to handle. Then we have cubic polynomial which on reducing will look like this, right? And we have again similar a minus b the whole square into another term, again a cubic polynomial. And sometimes we will be able to handle combination of reducible and non-reducible. So this is a cubic polynomial which can be reduced to a linear equation into a quadratic equation, not equation, sorry, expression, which cannot be further reduced, cannot be further reduced. So all in all, this is the column that we are looking at. Okay, so we have px plus q divided by x minus a into x minus b, that can be reduced to a by x minus a plus b by x minus b. So what exactly is this? How to make use of this table? We're going to understand it. So this in entirety is called as integration by partial fractions. So the purpose is to handle rational functions by doing the following actually. Okay, let's look at how to do this. First thing is the degree of the numerator should be less than the denominator. If not, we will do long division. Then factorize the denominator into irreducible fractions. So you need to factorize. I mean, the whole topic is so. It's not that we have to do it any point of time. No. In exam, you might not be able to reduce them. Then we have to use different methodology. If we are able to reduce them, then we have to use this methodology. Again, this process will be faster. That's the whole point. Express the rational function as sum of partial fractions with simpler denominators. So this is where the funda is. Okay, so that's what I have to explain it to you guys. Then determine the unknown coefficients by equating the numerators of the partial fraction to the original numerator. Integrate each partial fraction separately, sum up the integrals, so on and so forth. So I want to talk about the partial aspect, partial fraction aspect. Other things are to be done later on. Integral part is just use a formula, so that's not a big issue over here. Okay, first thing is let's look at the degree. The degree over here is correct 2 and the degree over here is correct 1, right? Now we'll consider the denominator, and now we need to split them, factorize them, right? So degree of the numerator has to be greater than denominator, sorry, lesser than denominator, that we saw. The next step is factorize. So this is quite simple. We can use any method. I'll use splitting the middle term. And we have here x plus 4 into x minus 2. Okay, this is where that partial thing comes into picture. I'm going to write a by x plus 4 plus b by x minus 2. This is where the table comes into picture. You guys got it? This is where the table has to be used. This is where the table has to be used. Okay, right? So we can see that in the denominator we have a plus b into a minus b. Not exactly actually, x plus a into x minus b, something like that. So it's of this form, so I wrote it. I wrote the partial fraction in this manner. Getting it? So after this is quite simple. Only the table is useful at this point. After this, you just have to equate it to the original expression. 3x plus 4 divided by x plus 4 into x minus 2. And taking the LCM, 3x plus 4. Of course, in the denominator, we again have x plus 4 into x minus 2. It's a simple LCM, nothing else. So it's similar to what we did in the last set of questions. So what happens over here? The denominator gets eliminated. All I have to do is substitute values for x, or the other ways of solving it. I like to substitute. It's kind of simple and straightforward and fast, to be honest. So I'm going to use that. What do I mean? I'm going to substitute x is equal to 2. What will happen? A into 2 minus 2. This becomes 0, right? That's the whole point. And this is 2 plus 4. And this would be 3 into 2 plus 4. So b is equal to, this is 6 plus 4, 10 by 6, that is 5 by 3. Right? So all we have to do is substitute values and find the unknown. And next is we need to solve for a. So we're going to substitute x is equal to, so since we want a, I need to eliminate b, say minus 4. So that would be minus 4 minus 2 plus b into 0 minus 3 into 4 plus 4. Okay, that looks good. So this would be a is equal to, that is minus 12 minus 8 by minus 6. So this will reduce to, so this would be plus, first thing, 2 4s are and 3s are 4 by 3. Right? And so finally we have the original integration in a very simple manner. So a times of dx by x plus 4 and b is plus 5 by 3 dx by x minus 2. And after this you guys know what to do. So, and then the process continues. Okay, so that's what we did, right? Degree, factorize, express in the simpler manner with simpler denominator. That's what we did over here, right? It became simpler. Determine the unknown coefficient. We found a and b. Integrate each partial fraction, that is to be done in the future, and add them up, right? So the entire funda was partial fractions. I'll do the verification over here. Verification of this particular set of numbers will lead to what we need. So this we have x minus 2 if I'm right, and 5 by 3 is with x plus 4. So this is 4 by 3. I'm matching the x's and then the constant. So we have minus 4 by 3 into 2 plus 5 into 4 by 3. And this would be 9 by 3, so 3x minus, this is 8, this is 20, that would be 12, and 12 by 3 is 4. Oh, wait, this is plus, by the way, 20 na. So this is your numerator, see, and the denominator will, if you take the LCM and all of that, we will get back the denominator. So you understood? That's the whole point of partial fractions. So we're not any point of time moving away from the original expression, just that we are re-expressing it in all these places. Okay, yes. Yeah. Learn the pattern. If there is a square, then we need to have two terms. Then if we have x minus a into x plus x minus b, then we have again two terms, but in this manner. So if there is a combination of square and a linear expression, then it's of this manner, combination of whatever we just saw before. And if we have things which cannot be further reduced, then we have something like this. So all of this is present over here, so you guys have to memorize. Okay, only this table. And it's not that hard also, to be honest.